This lesson is over a factoring review. Question: how do you know which type of factoring to use? Well, the answer? You look for clues. Here's a few steps we're going to try. First, make sure it is arranged in the correct descending order. And by descending, I mean according to the highest exponent first. Second, we factor out the GCF, the greatest common factor, if possible. Third, we look at the number of terms. If you have two terms, you look for a pattern, such as difference of squares. If you have three terms, you factor using the AC method, which is where you multiply your first coefficient times your last coefficient and you create a list of values. If you have four terms, we factor by grouping. From then, you look and see, can it possibly factor again? Now, if the parenthesis set is linear, which means it just has an x or a variable with no exponent, then it cannot factor again. Let's look at a few examples. Example 1, factor completely. For A, we have 3x squared minus 18 minus 3x. So first, we need to check the order. Is this in the correct order? No. The correct order should be 3x squared minus 3x minus 18. Next, we look for a GCF. Take a moment to see if you can identify a GCF. It turns out the greatest common factor is a 3. So we need to divide each and every term by 3 for us to factor out a 3. And when we do that, the first term reduces and leaves us with x squared. The middle term reduces to leave us with negative x. And the constant reduces to negative 6. And so we factored a 3 out, and now we are left looking inside the parentheses. How many terms do you see inside of the parentheses? There's 3. And when you have 3 terms, it means you will factor using the AC method. Now this will take some time and quite a bit of space, so we are going to do some side work on the side of our paper. The part we're concerned with is x squared minus x minus 6. To do the AC method, we multiply our leading coefficient, which in this case is a 1, times our constant, or our last number, which is a negative 6. And so 1 times negative 6 gives us negative 6. From here, we create a list of multiples, and it's best to go in order. 1 times what gives you 6? 2 times what gives you 6? 3 times what? 4 times what? And so on. In this case, we only have 2 possibilities. Since our list is complete, now we go back and look. The result was a negative 6. We're concerned with the sign. If it is a positive, it means we add. If it's a negative, it means we subtract. And if we subtract, the result has to equal the middle value, or the middle coefficient. Our middle coefficient is a negative 1. And so looking at our list, can 1 minus 6 ever give you negative 1? No. Now 2 and 3, could you ever subtract 2 and 3 and ever get negative 1? Yes. But here's where we have to be careful. The order is very important. Would it be 2 minus 3 or 3 minus 2? For us to get a result of negative 1, it would be 2 minus 3. And so now that we found our values, what do we do with them? Well, we expand the middle term. Instead of leaving it as negative x, we replace it with the values we just found. It's a positive 2x and a negative 3x. And we keep the other terms just as they were. So we've gone from 3 terms to 4 terms. Why is this helpful? Well, when you have 4 terms, you can do factor by grouping. So we look at the first 2 terms, x squared plus 2x, and we notice they have an x in common. And when you factor out an x, it leaves you with x plus 2. Now we look at the last 2 terms. We have a negative 3x minus 6. And notice they have a negative 3 in common. And when you factor out a negative 3, it leaves you with x plus 2. Looking at our first term and our last term, we now notice that x plus 2 is common in both terms, so we factor out the x plus 2, and that leaves us with x minus 3. So we have completed the A times C method. Now we bring this back to the original problem. In place of x squared minus x minus 6, we now write x plus 2 times x minus 3. But we're not done with the problem. We cannot leave the 3 behind, so you must keep the coefficient, or the GCF of 3, out in front. The last thing is to see if this can factor again. Well, if you look at x plus 2, is that linear? Yes, we know it's linear because x is not raised to a power. Is x minus 3 linear? Yes, because it is not raised to a power, which means 3 times x plus 2 times x minus 3 is your final answer. For problem B, we have 15x to the third minus 5x minus 2 plus 6x squared. First, we need to check the order. Notice it is not in the correct order. The correct order should be 15x to the third plus 6x squared minus 5x minus 2. Next, we look to see, is there a GCF other than 1? And in this case, there is not, but at least we checked. So now we investigate, how many terms do you see? There are 4 terms. And when you have 4 terms, we must do factor by grouping. So we look at the first 2 terms, and we notice they have a 3 and an x squared in common. So we factor the 15x cubed and the 6x squared. We divide both of those by 3x squared, which leaves you with 5x plus 2. Now we look at the last 2 terms, negative 5x minus 2. Well, there appears to not be a common factor, which means our GCF must be 1. The other thing is, because it's a negative 5x, we always take the sign of the leading number. So we will factor out not 1, but negative 1 from both values, which leaves you with 5x plus 2. Now we have 2 terms, but notice both the first term and the last term have a 5x plus 2 included, so that is our common factor. And when we factor out 5x plus 2, it leaves us with 3x squared minus 1. The last step is to determine, can this factor again? The first parenthesis set, 5x plus 2, we look, is that linear? Yes, which means it cannot factor. We look at the next parenthesis set, 3x squared minus 1. Is that linear? No, which means we must investigate and see if it can factor further. 3x squared minus 1 is actually a quadratic, but we look at how many terms we have inside that parenthesis set. Since we have two terms, we look to see if it follows a pattern of difference of squares. Is 3x squared a perfect square? No, which means this does not satisfy the pattern of difference of squares, so it cannot factor, which means this is your final answer, 5x plus 2 times 3x squared minus 1. Problem C, we have m to the fourth minus 16. First, we check the order. Is it in the correct order? Yes. Next, we look for a common factor. Do they have anything in common? No. So then we move on. How many terms do you see? Well, it turns out we have two terms. And when you have two terms, we look for patterns, specifically difference of squares. So the first term, m to the fourth. Can you think of any value times itself that would give you m to the fourth? Yes. Is 16 a perfect square? Yes. Is there a minus sign? Yes, which means this does satisfy the difference of squares, so it will immediately factor into two parentheses. Now, what times itself would give you m to the fourth? Well, that would be m squared. What times itself would give you 16? Well, that would be 4. And what do we know about their signs? One's a positive, the other's a minus. Now we have to check. We have factored it, but now we need to look at each piece. The first parenthesis set, m squared plus 4. Is that linear? No, because it has m squared, that means that is quadratic. So we need to see if it can possibly factor again. So we look at how many terms we have inside the parentheses. We have two terms, which means we look for difference of squares again. Is m squared a perfect square? Yes. Is 4 a perfect square? Yes. Is there a minus sign? No, which means this does not satisfy the pattern of difference of squares, so it cannot factor. So we've checked the first parenthesis. Now we need to check the second parenthesis. This one is m squared minus 4. Is this linear? No. This too is quadratic because it has m raised to a power of 2. So we investigate. How many terms do you see inside the second parenthesis set? Well, there's 2, which means we need to look for a pattern, specifically difference of squares. Is m squared a perfect square? Yes. Is 4 a perfect square? Yes. Is there a minus sign? Yes, which means this does satisfy the difference of squares pattern, so we need to factor it. And so that would factor into m plus 2 and m minus 2. Now, although we factored the second parenthesis set, you cannot forget the first parenthesis set. M squared plus 4 cannot be factored, so it must move to the next line. So now we appear to have 3 different parentheses. We need to check again. Can m squared plus 4 factor? No, we checked that earlier. We look at the next set, m plus 2. Is that linear? Yes, because it's m raised to no other power, which means it cannot factor. Is m minus 2 linear? Yes. So we've checked everything, nothing else can factor, so your final answer is m squared plus 4 times m plus 2 times m minus 2. Problem D, 5m plus 2m cubed minus 14m squared minus 35. This is your try it problem. Let's see how you did. Hopefully you found it to factor into m minus 7 times 2m squared plus 5. Problem E, 24c squared minus 44c minus 28. This too is your try it problem. Hopefully you were able to factor it into 4 times 2c plus 1 times 3c minus 7.